Now we are going to see the voltage and feedback amplifier, and the aim of this experiment is to design the voltage and feedback amplifier with the VCC of 10 volt and IC equal to 1.2 milliamps and AB equal to 30 and F1 equal to 1 kilohertz with stability S equal to 2. HFE is taken as 150 and beta is equal to zero point 0.4. The apparatus required is given here for the circuit diagram as per the circuit diagram, and the connections are given. If we suppose to use, we have to use the multisim software, we can take these components in the multisim tool and we have to connect them, and the design procedure is given here. We have to calculate the value of RC. This is the circuit diagram of voltage and feedback amplifier. We are going to obtain the frequency response. So that we are given a network. Voltage and network consist of connecting base to collector, a resistance called as feedback resistance. We are giving an input signal and we have to study the characteristics of the frequency response. We have to vary this frequency and measure the output voltage. See, this is the truth table. We have to vary the frequency and measure the output voltage, and we have to calculate the gain. The other parameters which we have to calculate is R1, R2, resistance, input impedance. This is the graph for the without feedback and with feedback. Okay, without feedback normally have high gain but lower bandwidth. But with feedback will have low gain but higher bandwidth. Okay, now we are going to see the output for this voltage shunt amplifier. See, this is the circuit diagram of voltage shunt amplifier. Okay, see, this is the circuit diagram for the voltage shunt amplifier, and here we have given see, this is the circuit diagram for voltage shunt amplifier. The input signal is a sinusoidal waveform, and we are going to measure the, if we see the input output characteristics, the input signal is a blue color indicated sinusoidal signal and the output is a violet color indicated sine wave signal which is amplified. If we want to see the frequency response, we have to move to the AC sweep and we can simulate and see the frequency response output. See the frequency response in the frequency as magnitude in dB scale. We can see the frequency response, how it was obtained. The phase as well as magnitude plot can also be obtained. Similarly, for another type of amplifier, we are going to see here is current series amplifier. Here the connections are similar here, that RE is connected parallel to the CE with the feedback resistance at the RC terminal, and R1 and R2 R1 and R2 as a biasing capacitance. This is the current series feedback amplifier circuit diagram, and the connections are should be given as per in the circuit diagram. We have to just with feedback network, the capacitance will be removed. Without feedback network, the capacitance will be added. Similarly, we can also see the output for the current series amplifier. This is the current series amplifier. Here it is without. It is with feedback. It is without feedback because capacitance is not given here. So that now we can see the input signal in the blue color and output signal in the input signal in the green color and output signal in the blue color. For each sinusoidal input waveform, the amplified waveform is obtained at the output. Similarly, we can also see the AC sweep response, that is magnitude as well as phasor value. Okay, this is the magnitude as well as the phasor value. That's all about the study of shunt as well as series amplifier circuit. Already shown in the voltage and feedback amplifier. This circuit is without feedback and this circuit is with feedback voltage, and here the output recording the magnitude response, that is white color indicates the high gain value. Here the output indicates the low gain value, but the bandwidth is very high for this with feedback when compared to without feedback signal. Okay, that's all about the voltage and feedback amplifier and current series feedback amplifier. Thank you.